some problems here. I'm not going to mention all the formulas again in this section. Basically, we have the linearity for the derivatives, and actually combine the sum rule, the constant multiplication rule, and together into one. And we also have the quotient rule and the product rule. Okay, there's 3 rules you need to memorize, and then the key formula, which much very useful, is a derivative of a power function. Okay, so 3 rules plus the formula. We don't call it the power rule, but in the book it says it's power rule, right? Yeah, the general power function. Yeah, product rule. Let's see. Okay, yeah, the power rule. This is a formula. It's a derivative of x to the any power, right? It's going to be like x to the n. It could be n times n minus x to the n minus 1. Okay, because we will deal with polynomials, the quotient of polynomials. Okay, I'm going to pick up problems from this section, and let's do one by one. So I'm not going to do odd number problems. You can if you want to do extra problem, there is answer key in the back side. Okay, so let's do problem. Number number 10. Okay, the problem number 10. You write down the problem. By, it's a function. Cy to the negative 6. So this is just a single function, right? A constant times function. So when you differentiate, you just take a constant out and differentiate y to the negative 6. Then you apply the formula. This is pretty straightforward, okay? The formula is going to be c times negative 6 y to the negative 6 minus 1. Right? So now you simplify a little bit, and this is the answer. Okay? So which formula we're using here? We use a derivative of we use a derivative of x to the power k. It's k to the x, right? K times x to the k minus 1. We also use a formula, the linearity formula. Here's a f of x plus b g of x, okay? And it's going to be the derivative of f of x plus b, the derivative of g of x, okay? This is called the linearity of the differentiation. Okay. So here we only have one term. B is gone, just f of x. A times f of x, just take a constant out. So those are the formulas. Now, then to problem number 12. Yeah, let's finish all of them, right? Y equals x to the 5 over 3 minus x to the 2 over 3. Right? We want to find the derivative function. Now, this is a sum of 2 power functions. So if you want to find the derivative, you have to find the derivative of each term, right? No choice. Just apply the above formula, linearity formula. Just differentiate each term. If it's a sum or subtraction, just differentiate term and keep the same relationship. Okay. And then you apply the above formula. K here is going to be fraction. So it's 5 over 3 x to the 0, 5 minus 1. Okay. Then you simplify a little bit. Okay. Then you simplify. That's 2 over 3 here, and x to the 1/3. Okay. Now, what's the meaning of the derivative? We already talked about before. You know, it's a limit of some ratio. Okay, the meaning of the derivative is a rate of change in y variable. So that's called the rate of change, right? If you give a variable and the y depends on x, y prime means the rate of change in the y variable with respect to x. That's the meaning of the derivative. Okay. Yeah, notation is different. You know, notation. Y prime means the derivative y with respect to x. Here, x is the input variable. If it's obvious, and then you just simply write y prime. Otherwise, you have to write dy over dx. Okay. All right. So let's do all of it. This is a third root of x, 2 plus x. This is a product of two functions. Okay. Now, how do we do that? Product. When we say product, immediately you connect this problem to the product rule, right? So you can use a product rule to solve the problem. Okay. So the product rule. Okay. If you differentiate the product of two functions, you differentiate the first function, copy the second function, and plus the copy of the first function and times the derivative of second function. Yeah, I keep writing this formula because I know when I was grading the test, there's still 1 or 2 students don't know what is a product and came to take a test. That's too bad. Yeah, I feel very bad about it. Okay, the product is a product. You get 2 terms. Okay, at least you should know product, right? Before you come to take a quick test. Yeah. And also, if you have to make up a quiz, I already gave you enough time, 1 week, right? So make sure you're ready for the quiz. Don't just come, sit in my office, I give the quiz, only can do the first problem and get 3 points, even the first one didn't do it. And that just wastes your time and my time. It's not good about that. You have to really prepare for the quiz, then come to my office, okay? All right, so product rule. That's a very natural idea. When I say natural, it's because the function is given as a product of functions, and I know there's a product rule I can use. So y prime is going to be x to the 1/3, right? And the derivative of x to the 1/3 is going to be 1/3 x to the 1/3 minus 1. Okay. Now the derivative of 2 plus x is just equal 1. That's it. You can simplify it, but this is the key part. When I grade your quiz or your test, I will look for this. Okay, I don't want to see just the answer. So it's 1/3 x to the negative 2/3, 2 plus x plus 1/3. I think this can be the final answer. Okay, but can you simplify a little bit? I don't want to see so many terms added together. And this requires algebra. If you're not good in algebra, maybe you cannot do that. Okay, so I take some terms out. I can take 1/3 x to the, watch out, okay? So the first term is just 2 plus x, nothing's left, right? But how to write the second term? Well, at least there's 3 here because 3 cancel out. And then you should have 2/3 x to the 2/3 x to the 1. And what you get is just x. So you get 2 plus 1x plus 3x, 4x. I think looks better. Why we have to do like that? Because if I want to find the zeros, so for y prime equals 0, right? Then you have to combine them. Otherwise, it's very difficult to find. You see, if I ask you to find to solve the equation. If I ask you to solve this equation, you cannot just give me the above. You cannot just give me this one, right? For example, if I want to solve y equals 0, right? Solve this equation, right? Which form is better? The last one. If you can combine those two terms into the product, then you can easily then you can solve this, right? But the first term never be 0, and then 2 plus 4x equals 0, x equals -1/2. See that? But otherwise, yeah, you get pretty complicated equation, right? The equation on the very top, if I set to be 0. If you're not able to solve it, that means you're not graduated from high school yet. That's a minimum requirement for the algebra. Graduate from high school. Okay, if you don't make mistakes like that, then you're good. Algebra, I said, algebra, you're good. Otherwise, don't claim you're good in algebra. Okay. Okay. So if I give you the equation like that, okay, and then -2/3, 2 plus x 1/3. Okay. So, if I meet some high school kids at a party, say, "Oh, I'm good in math." Okay, I give you this one. Can you solve it? Couldn't do it. Then that means you're not ready yet. Don't say you're very good in algebra. You need to practice. Okay, spend extra time on that because when you get to college, you will see questions like that. Okay, sometimes you skip the pre-calculus because you're good. Right? You get into calculus immediately, and you have to solve this type of question. Why? Later on, have we heard about the critical numbers like that, right? The critical numbers, you just find the zeros for y prime equals 0, okay? And you have to solve the equation. So even you given this equation, if you don't want to combine them, how do you solve it? Well, the idea is you have to get rid of x to the -2/3. So you multiply by each term multiplied by x to 2/3. Then x to the -2/3, x to the positive 2/3 will be gone. So you will get, okay, then this part will be just x. Then it's a linear equation. Then you can solve it, okay? 2 plus x plus 3x equals 0, then 2 plus 4x equals 0, and then x equals -1/2. You get the same result, okay? Yeah. So on every test in calculus, there was a problem. You end up with the equation similar to like that. So you needed to spend time to learn how to solve equations, okay? A typical, so the function like a third root of x times 2 plus x, like this function, if we want to sketch the graph, you find the maximum value or minimum value, and you do have to you have to look at solve this. You have to find the so-called critical numbers. We're going to study this later, okay? In chapter maybe 3, chapter 2. In chapter 3, we're going to study this later. All right, so let's move on to the next problem. Number 16. I don't want to skip any of the problems. Four pi r squared. All right, so 4 pi r squared, and what is it we do, right? Find the derivative, right, with respect to. Well, this is a, I don't know why it's a problem here. This is just a special power function. So all you have to do is just differentiate r, right? It's gonna be 4 pi r. That's it. So the variable, input variable is r. Right? When we say differentiate the function, means differentiate the function with respect to the given input variable. Right? The input variable by default is r here. Right? 18.
Shouldn't that be 8 pi r?
Yeah, 8. You're right. You see? I lost point here. 99 this time. This is a proof, right? I cannot get 100% on the take this test. Okay. So square x plus x over x squared. I think my mistakes is I skipped some steps, because when I write down r squared prime, I didn't even write down the result for r squared prime. I immediately jumped to the answer. Okay, if I write down 2r, then I can get 8. Okay, so sometimes skip steps will cause problems. You think it's trivial, then you end up with wrong answers. How about this, right? Find the derivative. Now, this is given as a quotient, okay? But does not mean you have to use the quotient rule, okay? Quotient rule is more complicated than the product rule. The product rule is more complicated than the linearity rule. We call it linearity rule, okay? Yeah. And so in this case, I would prefer to express in the following form. I separate it, okay? So here will be x to the 1/2 minus 2, and here's 1 minus 2, right? So let's simplify it. Okay, so it's sum of 2 power function. Now we can also do similar way for the above problem. Okay? You can use a quotient rule, but try to avoid the quotient rule. Okay. How do I know that? Well, that's my experience. I find out it's very complicated. Okay. Okay, you probably get this experience too, if you're trying to do that directly. All right, so y prime is good. Okay. Then using the formula, maybe I also don't simplify immediately, because it's hard to figure out what is -3/2 minus 1, right? Okay, put this. Actually, even you make computation mistakes, you get more credits. Okay, 3/2. Okay, this will be done. You don't need to combine them. Now, here's the question again. If I set this to be 0, can you solve it? That's my question. I give you 1 minute. Okay, solve this equation if possible. Okay, x cannot be 0, but are you able to solve it? Because in calculus, you will see many questions like that. Involve negative power, involve a negative fraction power. No, the power is fractions. All right, so x cannot be 0. So I would like to multiply x to the 5 over 2. I don't like negative power, so if I use that, I can get all the positive powers. The first term will be just negative 3 over 2, because other two terms, x to the negative 5 pi over 2 times x to the positive 5 pi over 2 cancel out, minus x to the 5 pi over 2 minus 2. 5 pi over 2 minus 2 is going to be x to the 1/2. Okay? Now, in other words, x to the 1/2 is going to be 3 over 2. X to the 1/2 is going to be negative 3 over 2. Well, you can say, okay, I'm going to square it. Okay, square it. But this procedure will get more solutions than you want. Actually, that's no solution. No solution. Okay, why no solution? Okay, when you're given an equation, when you square both sides, you will get a new equation which is it's not equivalent to the original equation. It will have more solutions. So the new equation is very simple, just x equals 9 over 4. The solution is x equals 9 over 4. But that's new equation. The original equation maybe has no solution. One is more than nothing, right? So this one has no solution. Why? Because square root of x never be negative. Obvious, right? Square root of x cannot be negative. So cannot be negative 3 over 2. Okay? So no solution. No solution to the original equation. Okay, okay, let's do the next problem. 20. G over 2. I think a t is inside. But so 5t is inside the rectangle. I think that this is already a sum of power functions. So very first step, you express it in this form. Line up, you know, every term is expressed in terms of a power function, right? T to a certain power k. Okay. Then you differentiate the derivative of the first term, and here's the derivative second term. So I get 1/2 just apply the formula for the power function, for the derivative power function. So now let's simplify it. So that's it. For this problem, if you want to find the 0, you can. Okay, it has a solution. Why? You see, think about that. This is a graph. Okay, t and the y equals g over t, right? G over t is going to be square root of 5 square root of t plus square root of 7 over t. So when t approaches 0 from positive side, this approaches infinity. When t goes to infinity, it goes like that. So there should be a point where the derivative is 0 because it's changes the lines is horizontal. So from the graph, I can tell g prime of t equals 0 has a solution. Okay, why the both sides goes to infinity? Look at the graph. because when t approaches 0 from the positive side, square root of 7 over t approaches infinity. That's why I go, when t getting close to 0, the graph getting high. But when t approaches infinity, you can ignore the second term because square root of 7 over t approaches 0. But the first term, it's actually is a constant times square root of t. Square root of t approaches infinity. So that's why I have to also, the graph had to go up. So both sides go up. There's somewhere, there's a minimum point. So at that particular point, the lowest point, the tangent line is horizontal. Okay, you should have a solution. So before you solve the equation, you can tell that at least that's one solution. Then you can do that. You know, look at this is another good example to see if you want to set g prime t equals 0, you can find a solution. Okay. But I'm not going to do that to just show you the example. There's a solution there. Okay. So you can set g prime t equals 0, and you can get one particular solution. Okay, Q22 d over t is going to be 1 plus 16t squared 4t cubed. Okay, so far I haven't applied the quotient rule to any of the problems, and I don't think it's needed right now, even for this particular problem. It looks like a quotient of two functions, but I can express it as a sum of power functions. Okay, so what I'm going to do is give me 16, no, not 16, 64 t cubed. Okay, so it's going to be 1 over 64 t cubed plus 16, it's 4. Okay. 16 over 64 is 1 over 4. T squared over t cubed is 1 over t. Okay, you still have to express it as a sum of a power function. Then you find the derivative. Okay. It's a derivative of t to the negative 3. Okay. So let's write down the details. It's negative 3, 64. Negative 3 minus 1, negative 4. So this is the answer. All right, we did all the problems on the left-hand side. So we're going to do the new type of problems. You may have to use product rule. Sometimes it's better. Okay, or quotient. Q26. So BU equals U cubed plus 1, 2U cubed, 2U squared minus 4U minus 1. This is a product of two polynomials. I'm pretty sure it's a polynomial again. So you have the options. Either you multiply them out and then you find the derivative of the polynomial. Or you just apply the product rule to find the derivative. Okay, it's up to you. I'm not going to multiply them out this time. I'm just trying to use a product rule to find the derivative. Okay. So I get 3U squared See, if you do like that, you still have to do the multiplication to simplify. I don't know which way is better. Maybe you do the multiplication first. Right? Then you find the derivative of the polynomial. Otherwise, you have to do two multiplications here, right? The first one is okay, a little easier. The second one, you have 4 terms. Yeah, let's do this. Okay, so it's a 6u to the 4th power minus 12u cubed plus u squared. And then 4u to the 4th power plus 4u minus 4u cubed minus 4. Okay. And you put the like term together. Negative 16u cubed. Okay. Yeah. This and that. Don't forget this. This two already combined. Then minus 3u squared plus 4u minus 4. But you can also multiply this out and find the derivative of each term. So let's do the next one. Negative 28 jv equals vq minus 2v and the v to the 4th power plus v. Right? So this time I'm not going to apply the product. I multiply this out. Right? I get a power function, right? So this v cubed times v to the negative 4 would be v to the negative 1. And this minus 2v, 1 minus 4 is going to be negative 3. So it could be v to the power 1 minus 2v to the negative. Okay. So the derivative is going to be the derivative of each term here. You just write down the answer. Okay. Minus 2, negative 3, v to the negative 4, plus 1, minus 2, negative 1, v to the negative 1, minus 1. Yeah, it's minus 2. Okay, let's simplify it. So that's it. You know, we're not able to simplify it further a little bit. That first term and last term can be grouped together. See, I hope we can do the problems faster. I can do it. I already spent about less than 1 hour. How many problems did we? Did lots of them. We already did all the even number problems from the page. And this is a problem number 30. Find the derivative. Now we have to use the quotient rule. We are forced to use it. Okay, no choice. So very first step, you write down the details for this derivative. Okay, minus 6t plus 1, 6t minus 1, the derivative. So 6t plus 1, the derivative is 6. Right, so we have to be careful when you simplify it. So you get 36t minus 6 minus 36t minus 6. So 36 is gone. So you got negative 12, 6t minus 1 squared. I think it's the correct answer. Okay, find the derivative of this function. Well, just apply the quotient rule again. Okay, apply the quotient rule. This will be the denominator square, and then derivative numerator it's already 0, so we don't need to worry about this. And then 1 times the derivative of this term. Okay, 3t squared plus 4t. That's it. I cannot simplify further. All right, next one. Next one. Okay. I have to multiply this out to 1 u squared plus 4u plus 4. You can use a long division to simplify this a little bit, but it's okay. You can use a quotient rule directly. So it's 1 minus u squared and u squared plus 4u plus 4. Okay. And so it's 2u plus 4, 1 minus u. Are we able to simplify it? Yes. 2u plus 4 minus 2u squared minus 4u. So I have to group them together. Negative 2u squared, negative u squared. 2u minus negative 4u, negative 2. It's 2u. Okay, and then 4 plus 4 is going to be 8. It's the last one here, 36. Okay, again, use a product quotient, right? 2 plus x squared. And this is a derivative, 2 plus x minus square x, 2 plus x plus. Okay, the derivative of square root x, I know the answer already. I think the difficult part is how to simplify, right? So this is the answer. Yeah, 2 plus x the derivative is what? Now you can simplify it and have 2 plus x minus 2 times square x times square x. All right, so this is the final equation. I need to take one short break and give you a problem. I did a lot of them here. It's 38. Okay, find the y prime. Simplify. All right, the answer should be pretty simple. Okay, so y prime is 1 plus cx squared, cx prime 1 plus cx, right? I did it fast. Cx 1 plus cx prime. That's just formula, quotient. So 1 plus cx squared, and the derivative of cx is just c minus cx. So the derivative of 1 plus cx is just c. So the numerator will be just c. Why? Because I get c square x here minus c x squared. C square x. Okay, what else? Yeah. All right, let's do this. Now, we can use a product rule to solve the problem. But then when you're given any form of function, look at that. Are you able to simplify or trying to change it to a simple form? So make it easier to find a derivative. So I think you just simply multiply this out. And it's 2/3 plus 2, right? Minus 2/3 minus 2. Okay, 2/3 minus 2. It's going to be this. All right, now you find a derivative. The first term is 8 over 3. This is 3. 8 over 3 v to the 5 over 3. Okay. And the 2, 3 minus 1 is negative 1/3 plus 4/3 to the negative 7. Yeah, just differentiate each term one by one, you get this. All right, that's probably enough problems. Let's do different type, like a problem number 62. Okay, find the first and second derivative of the function f of x. F of x equals 3 minus x. We not only just want to find the first one, we want to find the second derivative, okay? So the first derivative, well, what method are we going to use, right? We have to use the quotient rule here. Okay, so the first derivative, you get 3 minus x squared 1 prime, 3 minus x minus 1 times 3 minus x prime. But 3 minus x prime is in the negative 1. So the first term is 0. No. Wait a minute. There's no such term here. I shouldn't line together just like this. Okay, so here it's going to be negative 1, right? So derivative of 3 minus x will be just negative 1. Okay, so the answer will be 1, 3 minus 2, 3 minus x squared. Okay, that's the first derivative. The second derivative is the derivative of the first derivative. Okay, you have to differentiate this again, 3 minus x squared and squared. And then the derivative 1 will be 0. And then derivative of 3 minus x squared, and then derivative. All right, how can I do this? How can I do that? 3 minus x squared, we cannot use the implicit differentiation here. So we have to multiply this out. It's going to be 9 minus 6x plus x squared. So when you differentiate, you get 0 minus 6 plus 2x. Yeah, just x. Okay. So now I take 2 out. So x minus 3 here, right? 3 minus x to the fourth power. So there's x, 3 minus x is common term. Right? So I can get negative 2, 3 minus x, change the sign. And then you get a negative 2, 3 minus x cubed. Yeah, just differentiate twice. Right, we suppose that f of 4 equals 2, G of 4 equals 5, F prime of 4 equals 6, G prime of 4 equals -3. Find the H prime of 4. Okay, here H4 is going to be f of x of g of x. Okay. So this is f of x, yeah, h of x is given, right? So we want to find out the derivative of h at 4. But we're not given a specific formula for f and g. So you have to write down the formula first. Okay. So this is a formula from the quotient rule, right? So then you plug 4 for x, you get g of 4 squared, f prime of 4, g of 4, f of 4, and g prime of 4. Okay, then you are given all the data above. F of prime of 4 is going to be 6, g of 4 is 5, minus f of 4 is 2, g prime of 4 is -3, g of 4 is 5 squared. Right? So this will be 36. So it's going to be 6 over 5 squared. Yes.
So when it comes 6 multiple 5 and then -2 multiple -3.
Yeah, that would be 6.
So
5 times 6, 30, plus 6, 36.
5.
Yeah. 5 times. Yeah. Yeah. It's going to be 30 plus 6. All right, so let's do a string problem here. It's a bonus problem, like problem number 82, a random picker problem. Find an equation of the tangent line. Maybe there are many, to the curve. The curve is y equals x minus 1 over x plus 1. So you are looking at the tangent line, but then those tangent lines are parallel to the line x minus 2y equals 2. Okay, so we're trying to understand the problem. So this is what is the line equation, right? Y equals y equals 1/2 of x plus 1 minus 1, right? So those two are equivalent. All right, so the line is here, has a slope of 1/2, and x is negative, right? So this is the line. This is a given line. And when x equals 0, it's also passing through. Okay, this is a graph. Graph is somewhere here. I don't know. I cannot sketch a graph like that, right? So anyway, the graph is not defined when x equals -1. And maybe like that, right? But when x equals 1, and the graph passes through the point when x equals 1. So we are looking for the tangent line such that the tangent line is parallel to the given line. So the slope of this tangent line is going to be 1/2, right? So as long as another line has a slope 1/2, and then that line is parallel to the given line. At arbitrary point, okay? So the arbitrary point here, it's going to be B, right? I want to find the slope of tangent line. So clearly, B is not arbitrary. B is going to be A minus 1, A plus 1, right? Otherwise, this is not the point on the graph. And I'm going to find a slope at that point. That's a P. So the slope MP is going to be the derivative of y with respect to x when x equals a, right? All right, so I'm going to find the derivative. It's going to be x plus 1 square, x minus 1 prime, x plus 1 minus x minus 1, x plus 1 prime. So the answer will be x plus 1 minus x minus 1. It's 2x plus 1 squared. Okay? So you find the derivative. This is general. But when x equals a, and that is going to be 2 plus a plus 1. And that's a slope of the tangent line at the slope at a and b. But if the tangent line parallel to the given line, if and only if the slope equals 1/2. Okay, the tangent line is parallel to the line we already have here, y equals 1/2 minus 1, 1/2 x minus 1, if and only if the slope of tangent line is going to be 1/2. All right, so you can solve it. Okay, it's another strange equation, right? You can multiply that. It's 4 equals a plus 1 squared. Now what is the solution? So a plus 1 equals plus minus 2. A equals negative plus minus 2. So there are two possible solutions, negative 3 and 1. All right, so you find the point. What do you have? You find the equation. Yeah, so you have to find the equation of tangent line. You already find the slope. Okay, so when a equals negative 3. Okay, so the x, this is a, right? And the b is going to be what? B is going to be a minus 1, a plus 1. So negative 3 minus 1, negative 3 plus 1, negative 2, right? B is negative 2. Okay, so you know the point, you know the slope. So y minus negative 2 is 1/2 x minus negative 3. This is the equation for the tangent line. When a equals 1, b is going to be 1 minus 1, 1 plus 1, which is 0. Okay. So then in this case, y minus 0 equals 1/2 x minus 1. Okay, so you get two tangent lines, and both have the same slope of 1/2. Both are parallel to the given line. Okay, let's go over this problem again. So we are looking for the points on on the curve at which the tangent line is parallel to the given line. The given line has a slope 1/2. So all I have to do is just find those points whose slope of the tangent line is going to be 1/2. So pick up an arbitrary point, then the coordinates are A and B. B is equal to A minus 1 over A plus 1. And calculate the slope of the tangent line, which is a derivative of a function. And after simplifying it, just 2 over x plus 1 squared. Okay. The slope of the tangent line is going to be A over A, 2 over A plus 1 squared. So this should be equal to 1/2. Otherwise, they're not parallel. So once in 1/2, you can determine the value for A. So that's it. And